Okay, so like I said, today we are doing indicator 17.3, and we are dividing, sorry, terrible handwriting. I have to hover my hand and it just makes it almost impossible. We are dividing monomials. Okay? And if you did the Khan Academies, this was discussed in the Khan Academy video. And so there's a couple of steps. I want you to write these down. So step 1 is you divide, and I'm going to get lazy here. You divide the numbers. Okay? Step 2 is each variable or letter, okay, one at a time, and you subtract the bottom from the top. And I'll show you kind of a shortcut way to do this. There's a math way to do it, and then there's just kind of I call it the visual way. I think the visual way is easier. I will show you both, and however you want to do it is fine with me. And I'll show you what I mean when I go to give you the examples. I'll show you both ways to do it and explain to you why I think one's easier than the other. Okay? All right, so let's look at example number 1. So we have 30 a to the 4th b squared over 3 ab. Now, the way I like to do these is I like to give myself a fraction line, kind of like when you're building a house and you build the frame first and then you know what to build around the frame. For me, this is a frame. And sometimes you won't always use the bottom and it just becomes, you don't really put a 1 on the bottom. But I think this helps just to kind of keep straight of where you're putting things. Are you putting things top or bottom? And that's all you have to decide. So in this one, you've got first, just look at the numbers. And I can't cover it because can't really cover the screen. But if I was to put my hand over the A's and the B's and it was just 30 over 3, how would you reduce that? 10 on top or bottom? Yeah, the bigger number's on top. So the 10 goes on top, right? And then, and you can, if it helps you to hold the mental place, it's really 10 over 1, because if you divide both the top and the bottom by 3, you get 10 on top and 1 on the bottom. All right, now look at your A's. First, I'll show you just the visual way to do it, and then I'll show you the math way to do it, okay? If you think of it, what's my exponent of my bottom A? A 1. What's my exponent of my bottom B? Okay, if I were you, I would jot those in, okay? They're not going to be there on your assignment. I would put them there. If I have 4 A's on top and 1 A on bottom, where do I have more A's? On the top, right? How many more up there do I have? I have 3. So it's A to the 3 on top. That 3 is quite the beautiful 3, isn't it? Not exactly. Let's try to write that so it actually looks like a 3. There we go. A little bit better. Now look at my B's. Where do I have more? On top. How many more do I have up there? 1. So my B goes on top. In this case, nothing went on the bottom. So you could leave it like this. That won't bother me a bit. Or you could just, that right there would be your answer, and you wouldn't need that 1. You do not have to put the 1 there. And in most instances, I mean, if you saw a key that the computer generated, it would not put the 1 there. Okay? The math way to do it is you've got A to the 4 and A to the 1, and the step says that you subtract the bottom from the top. And so if you've got A to the 4 and A to the minus A to the 1, right, you get A to the 3. You get the same answer either way. For the B's, you have B to the squared and you have B1, and it says for division problems you subtract, right? And so you have B2 minus 1 is 1. So you get the same answer whether or not you do it mathematically or whether or not you just do it by sight. And the reason it works like this is because if I just say isolate my A's for a second, think of what a to the fourth means. It means a times a times a times a, right? That's on top, a to the fourth. And on the bottom, it was a to the 1, so just 1a. Well, what happens when you have a over a? What do? Oops, those two cancel each other out, right? So how many are you left with on top? 3. So either way, any way you look at it, it all comes out to being 3 A's on top. Okay, and so whichever way you think is easiest. All right, let's look at another example here. All right. So for this next example, we've got 3 x7 y6 z2 over 15 x5, or x to the 5th, I should say, getting lazy, y squared and z to the 2nd. All right, give myself a line to start building around. And if I cover up all the x, y, z's and I just have 3 over 15, how would you reduce 3 over 15? Yeah, 1 over 5. 3 over 15 reduces to 1 over 5. They're both divisible by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. Okay? Now I go one at a time, just through the alphabet. Where do I have more x's? Top. How many more do I have? So x squared is what's left over, right? 7 minus 5 is 2. Where do I have more y's? Top. How many more do I have? 4, because 6 minus 2 is 4. And where do I have more z's? They're equal. What's z squared over z squared equal? 1, right? Because if you subtract the exponents, you get 2 minus 2 is 0. What's anything to the 0 power? It's a 1. So I don't have any z's in my answer. That's my answer. Now, if you saw the answer like on an answer key that a computer generated, you don't even have to put this in your notes. It would probably look more like this without that 1 in front, but you do not have to clean it up for me like that. I am totally fine with what I squared up there for your answer. Okay? All right. Negative 18 m squared n to the 4 p to the 6 over 3 m to the 4 n to the 4 p to the 2. All right. Again, I'm going to give myself the line, and then I'm just going to write in line. I'm going to do numbers, then I'm going to do all my variables. So just looking at the number, negative 18 over 3, how does that reduce? Negative 6, and you can put over 1 if it helps you in your head block everything out, but you don't have to. Okay? Now, where do I have more m's? I have more m's in the bottom, right? I have 2 m's up top, and I have 4 m's in the bottom. So 2 of those m's get canceled out, leaving me how many in the bottom? M to the 2. And the reason it works like this, and I won't do this anymore, I just want to show you, if you have 2 m's up top, right, and you have 4 m's in the bottom, these 2 cancel out, leaving you with 2 in the bottom. That's the math behind why it works. Okay, so more m's on bottom, 2 more is, I have 2 of them left over when I subtract. So what about my n's? 4 and 4, what happens to them? You don't have any n's in your answer. How about my p's? Where do I have more p? Top, how many more? 4. And there's your answer. Now that negative 6 does not get flipped to the bottom. Why? It's not the exponent that's negative, right? You can have a negative number. That doesn't need messed with. It's only if the exponent is negative that you have to worry about flipping. Okay? All right. Let's look at one more example, and then I will give you your worksheet and let you run with it. And I'm going to pick something similar to you have on your worksheet to make sure, because the examples I had originally, some of the ones on your worksheet get a little bit harder, and I don't think that's very fair. All right. That's a Q, yeah. Give you a minute to get this written down. All right. You can do this one of two ways, whichever way makes more sense to you. I'll tell you both, and you can choose, okay? The 5/3, can that be reduced? Can 5/3 be reduced at all? It just stays 5/3, okay? That we don't do anything with. You've got some negatives here. I personally like to rewrite my problem and put everything in its proper place before I try to solve it. Meaning that p to the -4, where do I need to move it? In the top. The p to the -2, where do I need to move it? In the bottom. Same with that q to the -3. I need to move that up at the top. So I like to, before I do anything, I like to put everything where it goes. So I would leave the m to the 0 alone because it's in its proper place. I would put the p to the 4 up top because that gets rid of that 0, or that negative. I would leave the q2 in its right place. Then if you look at the bottom, that m to the 4 is just fine right now. It's not a negative I have to deal with. I've already put the p to the 4 up top. What do I need to bring down? P to the -2, I need to put it as a positive. And then that q to the -3, where does it need to go? Up top. All I did here in this step was I just stuck all the negatives where they needed to go. I put anything that was a negative on the other side of the fraction to get rid of the negative. Now I can simplify. I already said my 5 and my 3 don't simplify. Where do I have more m's? In the bottom. How many more do I have? 4, right? Because I don't have any in the top to cancel out. So my m's are done. Now look at my p's. Where do I have more p? Top. How many more? Okay. Now my q's. I had to move 3 of them up top. I already had 2 up top. How many do I have up top altogether? Yeah, it just gets added together. And that's your final answer. Now I am going to show you really quickly the math way to do it if you don't like moving things around like this, okay? Hang on, guys. Don't be packing up. I want you to pay attention to what I'm doing here, okay? My m's I'm not going to mess with. We already know they go on the bottom, right? Now, if you do it the math way, you've got -2 as your exponent up top and -4 as your exponent on the bottom with your p's. So I would do -2 minus a -4, which would be plus, right? Does everybody follow me there? Because when it's a division problem, you subtract. So it would be -2 minus a -4, which would be plus. And -2 plus 4 is p to the +2, which there's my p to the +2. Okay? Then if I do my q's, I've got 2 minus a -3. So minus a -3 would be +3, which would give me q to the 5. And it ends up there as well. These two, right, are exact. I don't care which way you do it. If minus and a minus and all of that, and then sticking it where it goes, if that works in your head, I'm fine with it, because if you look at your m, it's 0 minus 4, which is -4, which is why you would put it in the bottom. All right? Okay, for those of you at home, click the load button. It should open up the assignment in Kami. Make sure you show all of your work, all of the steps that it took to get to the answer, and then submit it through Kami. And you guys have a great weekend.